Hello everyone. Today we're gonna talk about least count, first best guess, and uncertainty. So this all goes back to reading instruments, and this is gonna get us ready for the second part of that metric scavenger hunt that you did. All right, so let's get to it. We're gonna go in order. So least count is what we're gonna talk about first. We just read it LC because it's quicker. And what does that mean? Okay, so when you look at an instrument, there's a space between the tick marks. And it's in that space that you make a guess. So the space means something. You know, if the measurement comes between the two tick marks, it doesn't mean you round up or round down. You have to do something with that space. So in order to calculate, if you need to, the least count, you would take the any two adjacent tick marks and you would subtract them. Okay, and I'll do an example in just a second. But what this means is that the least count for a ruler, or the rulers that we use in here, is always going to be the same. The least count doesn't change depending on what you're measuring. The same with the spring scales and the tape measures and the trundle wheels and the balances and all the other stuff that you used the other day. All right, so here's an example. Here is a scale. It's in grams, and I can't use my cursor. Okay, and you can see that the lines are numbered 2, 3, 4, 5. And so 4 and 5 are adjacent tick marks. If you subtract them, you get 1 gram, and so the least count of that scale is 1 gram. Pretty straightforward. Gets a little trickier when you get into decimals. So here we go. This time, each individual line is not numbered like they were at the top, but there are more lines than the numbered lines. So what do you do with that? Well, why aren't the tick marks, for example, between the 14 and 15, why don't those have numbers on them? 14.1, 0.2, 14.3, etc. Any ideas? Well, it's because it would be too crowded and it would be hard to read. So those tick marks mean something. It's just they're not numbered because it would be really crowded. So looking at the example, it looks like I have put yellow on the 13.4 and the 13.5. So those are two adjacent tick marks. Take 13.5, subtract 13.4, and you get 0.1. So the least count of this scale is 0.1 grams. Notice they have units on the ends of them. And so that's pretty straightforward. Now, if you can remember this, the other two things fall into place, but you gotta understand this first, and we'll practice. Okay. Not all, but most of the instruments we'll use in here will have a least count that's a power of 10. So it'll be 100 or 10 or 1 or 0.1, 0.01. It doesn't always work that way, and then it gets a little trickier, but nevertheless, we'll try to keep this to be true all the time for the rest of the year. All right. Now we're going to get into first best guess. Okay. So let's go. Okay. So we already talked about the fact that the space between the tick marks has value, and you need to include that value. And you saw this when you did the readings on the calipers. So this is not totally new to you. So you need to make a reasonable estimate about the measurement when it falls between the tick marks. Now, the joy of the caliper was that the estimates were basically made for you by that little vernier scale down at the bottom, where your guesses would end in either a 0 or a 5. But that's the only vernier instrument that we use, so we have to sort of do this by hand now. The rule is, however, that you can only make one guess. And you have to make one guess. So you're reading the instrument, you get to the point where you have to guess, you guess that one, and then you're done. but you have to guess that one. You can't just leave it off. Okay. Why? Why are we doing this? Well, it's because your guess, your first best guess, indicates to the reader and to you how precise the instrument is. Way back when we talked about the fact that in an instrument, if an instrument can read out to more decimal places, then it's more precise than an instrument that can't read out that many decimal places. So the first best guess tells the reader, the precision of the instrument you're using. So let's do an example. So the white line is between the 3 and the 4 somewhere. All right, so we know it's 3 something. When we were doing calipers, some people were reading it as to rounding up or rounding down, and there really is no rounding. But as you look at that white line, is it less than halfway, more than halfway, or at the halfway point between 3 and 4? Well, it's more. So you know that it's got to be 3 point something greater than 5. Okay, so I'm going to guess, oh, yeah, this would be a good thing to do. First, look at the least count. So the least count in this case is 1 gram, because pick any one. 7 minus 6 is 1. 4 minus 3 is 1 gram. All right. So we know that. I took my guess as 0.7. You might have said 0.8. That is perfectly acceptable. 0.9, not so much, and 0.6, I think it would be closer to the halfway point. So I think for a first best guess of 3.7 or 3.8 is good. All right. Notice, I know this is a lot of writing, don't do that yet. Oh no! Sorry, just ignore me for a minute. All right, so first best guess is 3.7. Please notice that the least count is a 1 in the ones place. And notice that the guess is in the tenths place. So the guess is in the place value 1 to the right of the least count. The least count is in the ones, the guess is in the tenths. All right, so that's what this last part is about. The first best guess is always 1 place value to the right of the least count. And I mentioned this earlier. Any reading from a given instrument will always be taken out to the same first best guess place value, which is why when you read your calipers, you were either ending in a 5 or a 0 in your third decimal place, because no matter what, it had to go out to those 3 decimal places. Okay, so now you know about least count. You know about how to do first best guess. Let's see, I can't remember what the next thing is. Oh, uncertainty. So we're going to practice the least count and first best guess, but let's get the notes done for this, and then we'll go back and talk about it some more. Okay. When you are uncertain about something, you are not particularly certain. I don't know how else to say it. It's about confidence. All right. So how confident are you in your reading? Okay. So let's keep going. And theoretically, uncertainty could be any number you want it to be. However, because this is probably your first introduction to uncertainty, we're going to limit the choices you have to use as a number. This is going to be a little confusing, so don't worry. Take the notes down and we'll get to doing some examples, and I think that'll help a lot. So here's the deal. The spaces we looked at between the tick marks, and we talk about the fact that they have value, if you think you can visualize, you can take your eye and you can say, oh yeah, I can probably divide that in my mind into 10 places. Well, that gives you a good amount of uncertainty, because now you don't have to guess whether, for example, it's 0.7 or 0.8, because there'd be a line. I mean, there wouldn't be a line, but you could visualize a line for 0.7 or 0.8, which is what we did earlier. So your uncertainty is going to be the number 1. Now, in terms of the units that go on that and what place value it goes in, that depends on the instrument, and we'll come back to that, okay? But just if you have two adjacent tick marks and they're far enough apart that you could visualize 10 spaces in there, then your uncertainty is going to be a 1. If you can only visualize 5 spaces, then you're a little less certain, so you have a greater uncertainty, so you're less confident in your guess. Then your uncertainty is going to be the digit 2. All right, so just stick with me here. Okay. If you can only visualize the space being divided into 2 places, I should have said spaces there instead of places, but oh well, then you're even more uncertain, so your uncertainty is going to be a 5. So the greater the uncertainty, the less confidence you have in your guess, okay? So if you have an uncertainty of 1, that means, yeah, I'm pretty confident. You know, could be something else, but I'm pretty confident it's that. An uncertainty of 2 means, yeah, it'd be nice if it were a 1, but I can deal with the 2. It's not bad. I don't have as much confidence as I would have if I had a 1. And 5 means, yeah, this could be anywhere really between, 1 in 5 or 1 in 10, and I'm not really confident. Well, I'm not really confident, so my uncertainty is going to be larger. So you can do all this in your head if you want to. However, there is a formula that you can follow to sort of figure out, okay, should I use a 1 or 2 or a 5? So to get the uncertainty, which is the UNC, okay, the uncertainty, you take the least count, which you just figured out is the difference between adjacent tick marks, and divide it by the number of spaces you can visualize in your mind that you could put in between those 2 tick marks. And if you do that out, assuming you stick with the spaces visualized as being 10, 5, or 2, you're always going to get a 1, 2, or a 5. Anyway, we'll practice, so don't worry. All right, here we go. So we have the scale, which is, I think, the same as the one we saw before. But anyway, so the least count is what? Right, 1 gram. And how many spaces do you think you can visualize between the 3 and the 4? Now, those tick marks are pretty far apart, so I'm going to say I can visualize 10 spaces. I mean, I can estimate where the 5 is and, whether it's a 1 or a 4. So I'm pretty confident in this. So I'm going to say my least count is 1. My first best guess is 3.7 grams. So my uncertainty is going to be plus or minus 0.1 grams. Notice that the digit is a 1, and a 1 means I'm fairly certain because I could divide that space between the tick marks into 10 places. So the 1 isn't in the 1's place. In this case, it's in the 10th's place because the uncertainty is always in the same place value as the guess. And if you think about the definition of the word guess, guess means you're uncertain to some degree. So it makes sense that the uncertainty, how confident you feel in your guess, is going to be in the same place value as your guess. Okay, so there is that. We'll do some more. So notice, first best guess is 1 place value to the right of the least count, and the uncertainty and the first best guess are in the same place value. All right. Okay. Units. All the numbers, no matter if they're least count, first best guess, or uncertainty, must have units attached to them. Okay. So units, 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 units. Okay, so here we're getting into the practice. Okay, how should we do this? I'm going to recommend that you actually draw these scales, measuring scales, in your notebook. So why don't you take a few minutes and do that. Use a straight edge. The distance between your tick marks should be pretty good. It doesn't have to be perfect, but do the best you can, and then come back. Okay, so in this first scale, where we have 2, 3, 4, 5, they're all in grams. So the first thing I'm gonna do is figure out the least count. So what did you come up with for that? 1 gram, because 5 minus 4 is 1, and 4 minus 3 is 1. So no matter what tick marks you subtract, you're going to get the same answer. All right, now what about first best guess? Well, it's clearly more than 3. It's somewhere between 3 and 4, but it's certainly less than halfway in between 3 and 4. So I'm going to say 3.2. Now, if you put 3.3, that's fine too. 3.1, that's not a great guess because, I mean, it's clearly more than 1/10 of the way between 3 and 4. But anyway, so 3.2, 3.3 work fine. Now, what about the uncertainty? So remember, the uncertainty is based on how many tick marks you can visualize. So between 3 and 4, and those tick marks are pretty far apart. So I'm going to say I can visualize 10 spaces in there, which means my uncertainty is going to be a 1. But what place value is that 1 going to be in? Well, if you look at the 3.2, where's the guess? The 0.2. And the guess is the thing that you're uncertain about. So your uncertainty is in the same place as your guess, and you get an uncertainty of plus or minus 0.1 grams. You don't have to have the 0 in front of the 0.1, but it's a good habit to get into. It sort of draws the reader's eye to the fact that there's a decimal point there. So it's a good habit to get into. Okay, the next one is a little different, but the space between the tick marks looks approximately the same. But in this case, the adjacent tick marks are 30 and 40. So instead of a least count of 1 like we had before, what's the least count in this one going to be? Correct, 10 grams. All right, so notice that the 1, the 10, is really in the tens place. Okay, so let's look at the yellow line. It's somewhere between 50 and 60, and it's definitely more than halfway between 50 and 60. So I'm going to guess 56. Now, if you guess 57, that would be fine. If you guess 55, I'm going to say that's not fine because you can see that it's more than halfway in between. And 58 and 59 are just way closer to the 60. So my guess is the 6. I'm not guessing the 50 because there's a line that indicates 50, but I am guessing the 6. So automatically, what place value is my uncertainty going to be in? Well, the 6 is in the ones place, which means my uncertainty is going to be in the ones place. And because those tick marks are pretty far apart and I can visualize 10 spaces between them, I'm going to say my uncertainty is plus or minus 1 gram. Notice the uncertainties in the ones place and the guess, which is the 6, is in the ones place. All right, so here now it gets a little trickier. Looking at this next scale, it's similar to the first one. except that this time there are additional tick marks between the 3 and the 4, and you can actually see that there are now 10 spaces between the 2 and the 3 and the 3 and the 4. So, even though the numbered lines count by ones, those are not adjacent anymore. Adjacent is the 3 and the 3.1, right? So 3.1 minus 3 is 0.1. 3.5 minus 3.4 is 0.1. So the least count in this case is 0.1. Even though the tick marks aren't numbered, they are there, so they have value. And so you could pretend they're numbered. So the least count in this case is 0.1 grams. Now, the guess. Well, it's definitely between the 2 and the 3, so it's 2 point something, and it's 7, 8, so 6, 7, 8. So it's 2.8 something. The 2 is not a guess because there's a line. The 8 is not a guess because there's a tick mark for that too. So it's someplace between 2.8 and 2.9. Now to me, it looks like it's right smack in between 2.8 and 2.9. So I'm going to say my first best guess is 2.84. Oh, I could have said 2.85. Anyway, either way is fine. Anyway, so 2.84, 2.85. Notice that the 2 is not a guess because there's a 2. The 0.8 is not a guess because although it's not numbered, there is a 0.8 line, but the 4 is a guess. So automatically, where do you know your uncertainty is going to be? What place value? It's going to be in the hundreds, where the 4 is. Now, the question now is it a 1, a 2, or a 5? Well, if you look to me, I can easily divide those, the space in between those tick marks into 2 spaces. You might have better eyes than I do, which is fine. But I'm going to say that I could only divide it into 2 spaces, which means my uncertainty is going to be greater than it was, like in the first one. I'm not quite sure because, it could be a 4, could be a 5, could be a 6. So my uncertainty is going to be plus or minus 0.05. Well, why did I put the 5 in the hundreds place? Because that's where the guess is in the hundreds place. You're uncertain about your guess. So there's logic behind why it's in that place value. All right, one more. In this case, what do you get the least count to be? 1 gram. That's what I got. Okay, great. So it's between 45 and 46. So I'm going to say it's 45 something. I say 45.6. Now, you could have said 45.5. Yeah, I think those are probably the 2 best ones. So the 40 is not a guess because there's a line for it. The 45 is not a guess because there's a line for it. The 6, the 0.6, is a guess, which means what place is your uncertainty going to be in? Right, it's going to be in the 10th place this time. So looking at those lines, they're a little farther apart than the tick marks in the example above. So I'm going to say I could divide that into 5 spaces easily in my mind. So I'm going to call that a division into 5 spaces. So that means my uncertainty is 2, but the 2 is going to be in the 10th place. So there it is. So the uncertainty is plus or minus 0.2 grams. Okay, so I think we need some more practice. So I will have a practice sheet for you in class, or somebody will. Anyway, ask questions, please, and Thanks.